Okay. Today we are going to discuss the homework number 6. The homework number 6 is due tonight, and it is due tonight, and it is from the chapter 4. The probability is another homework from chapter 4. So today we are going to discuss the homework number 6, number 1. So let me show you. Yep, it is a number 1, but I want to make this bigger. And now I can share. Stop share. And let me share the, yes. Yeah, here. So, so can you hear me in the Zoom meeting, in the Zoom?
Yes. Yes.
Thank you. And can you see my writing also?
Yes.
I make the circle. It's good. Okay, thank you. Everything is good. Today here, we are going to discuss the two things. One is the joint probability, and the other one will be the marginal probability. So for the two probability, we are going to use the table. It's a 2x2 table. Here is a variable C, and this one is another one is R. So for example, let me assume the R1 is the male. So we have a 12 males, and R2, an example, female. Then that is the total number of students. For example, yeah, it didn't say anything, but let me say the R1 is the number of males, and R2 is the females, and 30 is the total number of students. Then now the question is how many females? So now 30 total, and we had 12 males, and the others must be 18. So we are filling the table, the missing counts. And now here, I don't know what is the C1, C2, but we have two groups for male, for female, right? So here's a 5, but the total males is a 12. So the other one will be 7, because we have to make the total 12. And now it's the same idea. Here's a 7. In C2 for female, and we figured we had 18 females. So the C1 will be 11. Then now we can take the other marginal total. It's a column wise, right? So here's the 5 and 11 will be 16, and 7 and 7, 14. And finally, even this way, it's a 16, 14. We are going to take the 30, the total number of students, right? So from the given counts, yeah, we can take the we can fill up the counts. It's the other cells. It's on the table. And now in part B, we need the probability of C1, just C1. Just C1. In the categories, C1 is male and female. Yeah, we had 16, right? So the probability, just C1, there is 16 students, male, female together, out of 30. Probably my labs ask us to simplify the fractions or the decimals, right? So it will be 8 out of 15, or even you can take the decimals, right? And also the next one is another one is R2, is R2 this way, right? It's among the female. It's only the female, R2. So here is 18. So now I can say the probability R2, there's 18. Yeah, 18 over 30. And simplify again, it's 9 over 15. I can one more time. It's a 9, I'm sorry, 3 over 5, or even the decimals, right? So in the probability of C1 this way, or probability R2 that way, we take the marginal total as divided by the total number of students, right? So this is the marginal probability. Then now the next one is a C1 and R2. See, one day we made the Venn diagram, A and B was in the middle. It's almost the same idea. C1 and R2, we need in the middle counts 11. So C1 and R2 in the middle, there's 11 out of 30. That is the joint. That is a joint probability. This one and this one in the joint, in the middle, we just count and take the probability. That is the joint probability. So from the table, we can make the joint probability from inside of the table, and even we can take the marginal total. Using the marginal total, yeah, we can take the marginal probabilities. We are going to use them, the joint probability and the marginal probability, for the next topic. The next topic will be the conditional probability, and let me take number 4, the question number 4, and copy here. Yep, it is number 4. Here is the notation, right? In the middle, there is a bar, and I can read it. It is a conditional probability. Actually, it is a D, conditional probability of F. Yeah, F was first, comma, given E. Yeah, E was given. So I can read the bar, it is a given. That means it's actually we need the probability of F conditionally. Depends on E. The textbook gives us a formula to get the conditional probability. F given E, it will be same as the joint probability of F and E divided by the probability of the given event. So please make sure who was given. Who was given? It must be in the denominator at the bottom. I just chose number 4. It is the simplest one for the conditional probability. Let me take another one, number 9 later. But number 4 gives us the joint probability E and F separately. The marginal probability, you know, the top one is a joint probability and the bottom one is a marginal probability. E was given is 0.8. So now simply we just take the ratio 0.6 over 0.8. It will be 6 over 8 as a decimal. That will be 0.75. So the 0.75 will be the conditional probability. It will be the conditional probability, 0.75, with the given probability, given joint probability, and given marginal probability. So with the joint and the marginal probability, we can take the conditional probability. So let me try again, number 9. Yep, here's a number 9. Yep, here's a probability for the bachelor degree. So let me summarize it here. It's the probability of the bachelor. That is a 0.726. And now we have another probability. You know, it is not clear what is that, but actually that is the joint probability. I mean, it is the probability of the bachelor and it's a women. The joint probability, which was 0.346. And the question is this. It's for me, it's not clear. It described the bachelor degree awarded to women, and this one is a bachelor degree were awarded to women. It's not clear for me, but the question asks us, what is the conditional probability? Women given bachelor. In the exam, I will ask you the clear one, but please try to understand which one is which in number 9, right? So now I can apply the joint probability and the marginal probability. So it will be same as probability of the woman and bachelor divided by the given part, the bachelor. You know, the bachelor and the women will be same as the women and the bachelor. So we can switch, yeah. So now let me plug the probabilities. The joint probability was 0.726 and the marginal probability was 0.346, the denominator. So we can take the ratio 0.726 over 0.346 will be I switched. I'm sorry. Yeah, I switched. Yeah, it is a joint one. So let me try again. 0.346 over 0.726. You know, in this way, I got 2 point something. No, never ever. Any kind of probability cannot be bigger than 1, right? So when you take any probabilities is bigger than 1, yeah, something wrong. Yeah, I switch. Yeah. Then the answer will be 0.4766. How many decimals? Only 1 decimal, and that is the percentages. So the answer will be 47.7%. Can you take the rounding to get the percentages? The answer will be 47.4. 7. What did I say? 47.7%. Good, right? Yeah. So we can apply the conditional probability. It's like this one. And let me go to number 12. Yep, here's a number 12. Last time, I gave you two cases, and or. Can you remember the table? We had A or B, and we applied the addition rule last time. And we had two addition rules. One was the special one, and the other one was the general one. When was the special case? When they were mutually exclusive. You know, when we make the Venn diagram, yeah, it is the A and that is the B, it's a separately. They are mutually exclusive. So in this case, for the probability of A or B, when they are special case, mutually exclusive, A or B, simply we just add the two probabilities. Yeah, it is the addition rule, probability of A plus probability of B. But the general case, the probability of A or B, yeah, absolutely, it is or. It's an or. We have to apply the addition rule, but generally, it's not only just to add the two probabilities, but we subtract in the middle, the common area. So which was the probability of A and B. So it was the general, it's a multiplication rule. But please look at the number 12. We need the probability A and B. The other case, and. Then now we can apply another rule. It will be multiplication rule. In addition rule, we added two probabilities. What do you expect? In the multiplication rule, we are going to take the multiplication. And we are going to have two cases, the special case and the general case. Let me introduce to you the general case first. When we need the probability A and B, we need the probability of A. Now we have to apply the multiplication rule. So times a conditional probability. It's a B given A. So please remember the order. Here is the unconditional probability of A, and here is the conditional probability given A. So that is a match. Here's a A, and there is a A. So it is the general multiplication rule. When do we need the probability? A and B. So now, look at this. We just need the probability A and B. Yes, by the general multiplication rule, it will be same as the probability of A times the probability of B given A. And they all given here. But simply we just take multiplication. You know, I just chose the basic problem. So before the conditional probability, and now by the general multiplication rule, is everything is given, right? So we just plug into the formula, we can get the answer. But the homework number 6 has many other questions, so you can do more practice with other questions. But now simply just plug the 0.8 and 0.45. So the multiplication will be 0.36. So let me check the answer. It's a 0.36. It's good, right? Yeah. And now we have another case, the special case, right? Let me try as a number 11 later, but now the special case is when they are independent. You know, as before, when we apply the special addition rule, they were mutually exclusive, right? But this one is another special case when they are independent. You know, please look at the conditional probability. So let me copy the conditional probability. B given A. Now, when they are independent. You know, before I explained to you, it is the conditional probability of B given A. That means the event of B depends on A. But now they are independent. What does it mean? What does it mean? They doesn't care each other. They don't care each other, right? So the conditional probability B given A, they are independent, then it will be same as just B. Because the event of B doesn't care what is the event of the A. It does not depend on independent. So now let me copy the general multiplication rule when we need the A and B again. But when the special case, when they are independent, then I just copy the first one and just simply times the B. Because the event of B, it depends on A. So the conditional probability, just B. So now we have two cases. Yeah, it's like this. It's big two cases. And or for the special multiplication rule, yeah, just simply take the multiplication, the probability of the A times the probability of B. But the special addition rule, yes, simply just take the addition of the two probabilities. But the special cases is a totally different. It is mutually exclusive and it is independence. Okay. You know, as a one, I emailed you. You can prepare the summary sheet in the exam. So in this weekend and no class on next Monday. So when you are preparing the exam, please prepare the cheating sheet, the summary sheet. It's a letter size, it's front to back. Anything you can copy, formulas and examples. Why don't you copy the table? So when I ask you, take the probability A and B, or A or B, then you can go this column, that column, or even I suggest to you they are independent. When they are mutually exclusive, then you can apply the special multiplication rule and special addition rule, right? So I can suggest to you, yeah, please copy this table on your summary. Then case by case, yeah, you can choose the right rule to get the correct answer. Okay, then now let me go to number 11. It is number 11. Yeah, they are independent. What did I say? I think yes, it is the correct answer. Because the event of B does not depend on A. So when I have B given A, it will be same as just B. How about this one? A given B. You know, it's actually, it was the conditional, I'm sorry, the probability of B. It is the probability of A, but it was the conditional probability. But when they are independent, it will be just B, and this one will be just the probability of the A. Okay, so now I can say the statement A, when they are independent, then we can say the conditional probability as will be just the probability of the first one, the first event. And now we have another example, it's number 13. So let me copy and paste number 13 is another example for the independence. Okay, this one, number 13. Now, when they are independent, you know the general multiplication rule for A and B, I mean the generally, which was the A times the probability of B given A. But now, it said they are independent. So, the conditional probability will be just B. And number 13, probability of A, probability of B were given. Yeah, we just simply into the formula. So the first one will be 0.7 and the second one will be 0.6. So the multiplication will be 0.6 times 7 times 6 will be it's 42. Okay, so let me check. 0.42. It's good, right? Yeah. So now, just a second. Yeah, I'm recording this Zoom meeting right now. So after class, I will email you the link. Yeah. So you can watch, you can study by yourself. It's one more time. Okay, so now I can summarize. You know, I can summarize. You know, basically in chapter 4, we have a big two topics, and I mean actually it's A and B, and A or B. And now we have two cases. It's a special case and the general case. When they are independent, and mutually exclusive, and you can copy the formula. That's it, right? You know, when you are doing the homework number 5 and 6 from chapter 4, the probability, it is. But here we had a conditional probability in the general multiplication rule. So because of that, additionally, we discussed what is the joint probability and what is the marginal probability for the conditional probability from the cross table. So basically we have a big two topics, right? And case by case. Yeah, when they're independent, when they're mutually exclusive. So please make a big table and please add the topics, the case, one by one, and please add more topics, more details, right? Then you can make the summary, chapter 4. So please, try the homework number 6 tonight. It's due tonight. Let me go back to the my labs, right? So this one is number 6. It's tonight, and already I posted the review homeworks. It's due 9. Let me see, 9. That is the next Wednesday, because you in class you will take the exam on Friday, right? But somebody in the Zoom, if you are in, I don't know what is the group number, but it's the other students will take the exam on Wednesday, right? And so because of that, the review exercises, review homework 7th, is due Wednesday. So please try the review homeworks. And please, if you have any question, please email me. So I can suggest to you, please try again all homeworks. Yeah, even though we are going to take the paper exam, but it will be similar as the homeworks, because not all of them, but most of them I just copy. I just copy from the homeworks and make the paper exam. So do you have any question? Do you have any questions in the Zoom? Just a second. How can I open the Zoom? I mean the chat window. Yeah, what is your question?
So group 1 is taking the test Friday.
Are you in group 2?
No, group 1.
Are you in group number 1? Then group number 1 will take the exam on Friday, because next Monday we don't have a class. So if you are in group number 1, then you are going to take the exam on Friday. If you are in group number 2, so we met last Wednesday, then you are going to take the exam on Wednesday. But if you have any schedule on the Friday, as I told you, you can take the exam earlier. Now I have it's 22 students, and I split 2 groups, 1 and 2. It's about 11 or 12 students each in each group. But in classroom, I have 13 seats. Even here, it's 13, 14 seats here. So if you want, I mean, you are going to take the exam Friday, but if you want to take the exam earlier, absolutely, you can be here on Wednesday. I have 1 or 2 seats available, but please email me, because at least I have to know how many students take the exam earlier, right? So if you cannot take the exam in the scheduled day, then please email me. Okay, yeah, we can make arrange. Maybe you can take the other day, or you can take the exam is any other time, is any other day. Good, right? Yeah. So do you have any other question for the exam? Then let me stop the Zoom meeting, and I will email you the link. Yeah, it's soon. So let me end the Zoom meeting. Thanks for coming.